Alright, so this part we are going to look at the law of conservation of mass. So we're saying this is law of conservation of mass. So what does the law say? It says that mass, or in this case we are talking about in terms of matter, matter is neither created nor destroyed, which means if you have a chemical reactions, the number of atoms you start with should be equal to the number of atoms you end with. So if you have a chemical reaction, the number of atoms you start with should be equal to the number of atoms you end with. And because of that, we use balanced chemical equation to fulfill the law of conservation of mass. So you have to use balanced chemical equation to fulfill the law of conservation of mass. Why is that the case? Because the balanced equation ensures that you have the same number of atoms you start with are equal to the number of atoms you end with. So that's the whole purpose of balancing a chemical equation. But first, I want us to look at 3 conditions necessary for a chemical reaction to occur. So first of all, for a chemical reaction to occur, there must be collision. That's the first condition. That is, species must collide. But not only the collisions must have sufficient energy, or they must have enough energy to react. So if energy is not enough, the collisions are not going to result into a chemical reaction. And the third condition is that these collisions must have proper orientation. So the collisions must have proper orientation. By that I mean the collision must be well directed. If they are not well directed, they are not going to result in a chemical reaction. So must be well directed. So those are the conditions necessary for a chemical reaction to occur. Now, here you also talk about a chemical equation. And the question is, what is this chemical equation? So a chemical equation is a symbolic representation of a chemical reaction. So, for example, if you have two hydrogen gas plus oxygen gas to give us two water liquid, this is a chemical equation. So this chemical equation is saying that we are reacting 2 moles of water and 1 mole of oxygen to give 2 moles of water. So let me make a correction. Here it's not water, it's oxygen, or it's hydrogen. So we are saying we are reacting 2 moles of hydrogen gas and 1 mole of oxygen to give us 2 moles of water. And you see here, every chemical equation has reactants. So what are these reactants in a chemical equation? So reactants are just the species that we are combining to react. So species that we are combining to react. That's what reactants are. For example, in the equation above, H2 and O2 are reactants. So you are going to find reactants on the left side of a chemical equation. So they are found on left side of your equation. That's where you find reactants. Then we also have products. Products is what we are forming after a chemical reaction. So those are products. So in this case, water is our product in the reaction above. And products are found on the right side of a chemical reaction. Now also, for a chemical reaction, you have a plus sign. A plus sign. The plus sign just means and. For example, we say hydrogen and oxygen react. So this and is plus. In this case, we say it's the same as 2H2 plus O2. So the plus sign just means and. That is adding the two species that are reacting. Then each chemical equation has coefficients. So coefficients are just they just indicate the lowest whole number ratio of each reactance. So these indicate the lowest whole number ratio for each reactant. So in our equation above, we said 2H2 gas plus O2 gas to give us 2H2O liquid. These ones are coefficients. So here there is a coefficient of 1, but we don't show 1. So these numbers indicate the whole number ratio of each reactant. And then there is this sign here. This sign just means to make. For example, we combine hydrogen and oxygen to make water. So that is what the sign means. Then we have the physical state. So the physical state is included in parentheses. Of each reacting species. So it just tells you that maybe the reactants are in liquid state, or the products are in liquid state or solid state. For example, if we take our example, 2H2 gas plus O2 gas to give us H2O, that is 2H2O liquid. This tells us this is a gas. This tells us this is also a gas. This tells us this is a liquid. So what we are saying is G stands for gas. L stands for liquid. So I'll put them in parentheses. S stands for solid. And AQ stands for aqueous. So these are the physical states of a chemical reaction. So we also talked about conservation of mass. So you do this by being able to balance chemical equations. So really, balancing chemical equations makes sure that you have the same number of atoms as reactants and products. So this ensures that mass is conserved. That's the purpose of balancing chemical reactions, which means the number of atoms on reactant side is equal to the number of atoms on product side. So that's the purpose of balancing a chemical equation. So let's just practice how to balance a chemical equation. So balance the following equation. So here we have H2 gas, O2 gas to give us H2O gas. Here we're adding plus energy. So how do you balance this equation? So to balance equation, you change the coefficient. To balance a chemical equation, change the coefficients. Do not change the subscripts. So do not change the subscript of any species. For example, if you want to change where I have labeled X. This is where you change. Don't change these. Do not change these subscripts. Never do that. Just change in these points. I have labeled X, X, X. That's where you need to change. So let's go on and write this equation again here. We say H2 gas plus O2 gas to give or to make H2O liquid. So we said to balance a chemical reaction, you need to change the coefficients. Don't change the subscripts. So what I do is I select one of the species in the reactant side or in the product side. I'll say hydrogen. So hydrogen. So I have 2 hydrogen atoms on reactant side. I also have 2 hydrogen atoms on product side. So for now, I will leave hydrogen the way it is because the hydrogens are balanced. Then I go to oxygen. I have 2 oxygen on reactant and 1 oxygen on product. So the oxygens are not balanced. So for me to balance the oxygen, I'll multiply water by 2. So multiply H2O by 2 to balance oxygen. So my equation will be H2 gas plus O2 gas to give me 2H2O liquid. Now in this case, I have 2 oxygen atoms here, also 2 times O. I have 2 oxygen atoms here. But then that produces, that gives me another problem. Now on reactants, I have 2 hydrogen atoms. On products, I have 4 hydrogen atoms. So what do? I need to multiply the hydrogen on the reactant side by 2. So I'll just say put 2 in front of H2 to balance hydrogen. So if I put 2 here, now I have balanced my hydrogen. So I'll come here and say I have 2 H2 gas, O2, but O2 is already balanced. So O2 is already balanced, so I just put O2 here. Gas, and then 2H2O. So let's count all the atoms. On the reactant side, hydrogen, I have 4 hydrogen atoms. On the product side, hydrogen, I also have 4 hydrogen atoms. So this is balanced. Oxygen, on the reactant side, I have 2 oxygen atoms. On the product side, I have also 2 oxygen atoms. So this is also balanced. So based on this, the equation is balanced. So let's look at another problem. So you don't balance energy, so you just leave the energy as it is. So I'll just say plus energy. Let's balance another equation. So balance C3H8 gas, O2 gas, CO2 gas, plus H2O liquid. Now for this reaction, always start with C. So a reaction like this one, where you have C3H something, C something, H something, start with C. So I'll look at the reactant side. We have 3C, and the product side we have 1C. So I will say balance C by putting 3 in front of CO2. That's the first thing you do. And then after balancing C, the second part is you need to balance hydrogen. Here, this side, we have 8 hydrogen. Here we only have 2 hydrogen. So we need to have 8 hydrogen here also. So we balance H by putting 4 in front of water. So what we are going to have is 3 here and 4 here. Now there is one thing that is not yet balanced. So let's do the calculation. So reactants, hydrogen, we have 8 hydrogen. Products, hydrogen, we have 8 hydrogen. So this one is balanced. Carbon, reactants, we have 3 carbon. Product, we have 3 carbon. So the carbons are balanced. But oxygen, reactant, we have 2 oxygen atoms. That's all, 2 oxygen atoms. Product, we have 4 oxygen atoms. So this is not balanced. So what we do is we balance oxygen. So balance oxygen by putting the oxygen, the product, we have reactant, we have 2 oxygens here. The product, we have 4 oxygens from here, and 3 times 2, 6 oxygens from here. So we have 10 oxygen as our product, not 4 oxygen. So that was a mistake. So here we have 10 oxygen. So you also want to have 10 oxygen here. So balance oxygen by putting 5 in front of O2. So we are going to put 5 here. So let me just rewrite the equation. So the balanced equation is C3H8 plus 5 oxygen. So let me put gas here, the state of matter, to give us 3 carbon dioxide gas plus 4 water. So let's do the accounting again of the atoms. So reactants, products. Reactant, hydrogen, we have 8 hydrogens. Product, we also have 8 hydrogens. Carbon, we have 3 carbon. Product, we also have 3 carbon. Oxygen, we have 10 oxygen. Product, we also have 10 oxygen. So this one is balanced. This one is balanced. This one is balanced. So if you look at the number of atoms, total number of atoms, so reactants, we have 21 atoms. Product, we also have 21 atoms. So we are saying balancing a chemical equation, just make sure that the number of atoms on the reactant side is equal to the number of atoms on the product side. So let's balance a little bit tougher one. So balance C4H10 gas, O2 gas, CO2 gas plus H2O gas. So the first thing is, as I said, you need to balance C. So we have 4 carbon here and 1 carbon here. So balance C by putting 4 in front of CO2. So I'm gonna put 4 here. So the second thing we balance is the hydrogen. So we have 10 hydrogens here, we have 2 hydrogens here. So balance H by putting 5 in front of H2O. So I am going to put 5 here. So oxygen must be the last one to balance. So we'll do the accounting again. Reactants, products. Carbon. We have 4 carbon atoms on the reactant side, 4 carbon atoms on the product side. Hydrogen. We have 10 hydrogen on reactant side. Then we have 10 hydrogen on the product side. So these two are balanced for now. Now let's go to oxygen. Oxygen. We have 2 oxygen on the reactant side. But look at the number of oxygen here. 4 times 2. So this one has 8 oxygens. Then 5 times 1. This one has 5 oxygens. So the total number of oxygens is 8 plus 5, which is 13 oxygen. So these are not balanced. The reason is we have 13 oxygen on this side, and we have 2 oxygen on this side. So how do we balance this? So I'll say balance oxygen by putting 7.5 on in front of O2. So you balance oxygen by putting 7.5 in front of O2. In front of O2. So I'm going to put here, I'm going to put 7.5 here. So what I'm saying is this equation as it is, it will become C4H10 gas plus 7.5 oxygen gas to give us 4 carbon dioxide gas and 5 water, also gas. Now, you don't want to have fractions on your equation like 7.5. You don't want to have 7.5. So what you want to do is multiply the whole equation by 2 to get rid of 7.5. So let's say I'll multiply the whole equation by 2. So 2 multiply 4 or C4 So you want to multiply the whole equation by 2. 2 multiply C4H10 gas plus 7.5 O2 gas to give us 4 CO2 gas plus 5 H2O gas. So when you multiply the whole equation, eventually we are going to have 2 C4H10 gas. 7.5 times 2 is equal to 13. 13 O2 gas. 2 times 4 will give us 8 CO2 gas. 2 times 5 will give us 10 H2O gas. So this equation is balanced. So that's how you balance reaction equations. And these are the types of reaction equations that you just need to make sure that you start with carbon and then hydrogen, and then you go on to balance oxygen as the last part. Now, and you know, balancing equation is mostly about inspection. So you are going to play around with some questions and try to balance these chemical equations. Thank you.